Okay, determining if a vector lies on a plane in 3 space. They've given us 2 vectors, or 2 component parts of vectors. -1, -2, 1, b of 3, -1, 1. I'm going to, without making as many lines as possible because it'll get very confusing, I'm going to try and show you what we mean by this. So, our x value is -1, y value -2, z value 1. Okay, so this point here, and technically, you know, we have our vector coming from there, and b is being 3, -1, and 1. So roughly here. Okay, these are in 3 space technically, and they make some plane. Okay, and the plane is essentially a 2-dimensional surface that cuts through both of them. So think of it like a wall, like we talked about before, but the wall, don't do that well, cuts through both of them. Okay, so let's do that in another color. So we have some plane that's cutting through. It's going like this, and it's kind of cuts through everything. Okay, so it's this plane that's cutting through all of the 3 dimensions. Okay, and what this question is asking is, does this final point here at -9, -4, and 1 lie in this plane? Okay, think of it like we've put a 2-dimensional space in a 3-dimensional space. And we're asking if this point of -9, like here, -4, and 1 lie in this plane. Who knows? We're going to figure it out. Okay, so what we're going to do, in other words, is again we're going to need scalars of our original 2, and we're going to set it equal to this. So still the same process that we did in the last question, just the idea being a little different. Okay, I'm going to draw a line on here because, you know, space didn't just disappear. Okay, so let's write that question out. Question says, what we're going to have is we are looking for some scalar of vector A. So this being our vector A, we'll call m the scalar for this one. -1, -2, and 1. And for some scalar of vector B, we'll call the other one, because I think it was called vector B, yeah, of 3, -1, and 1. And does this point, so this is our vector C, does this point lie in there? The point being -5, no, -9, -4, and 1. Yeah. Does that point lie in there? In other words, can I make scalars of these that will eventually get me to this point? It's the same idea, just 3-dimensional space. Well, we're going to have to do the same thing we did before. We're going to have to substitute our m and our n, distributive property, put it into all of these. So -m, -2m, and m plus 3n, -n, and n is equal to -9, -4, and 1. Well, we're going to make 3 equations this time because we have 3-dimensional space. So equation 1 is -m plus 3n is equal to -9. 2, -2m minus n equals -4. And finally, 3, m plus n equals 1. Oh, that's a nice easy one. M plus n equals 1. Okay? So we have this information. What we need to do is essentially find out what our scalars would be in this question. So we're going to substitute. We have 3 equations, 2 variables. We can solve this. We need to make sure, though, that what we solve for is true throughout all of them. So I'm going to take equation 3 just because it seems to be the easiest to work with. And m is equal to 1 subtract n. Okay. Well, I'm going to take that and then plug it into, let's say, equation 1. So equation 1 states that -m, so I put a negative sign outside of what this m used to be. And we have 1 minus n plus 3n equals negative 9. This becomes negative 1 plus n plus 3n is equal to negative 9. That gives us 4n is equal to negative 8. N equals negative 2. Okay? So I got a value of n. I'm just working with equations 1 and 3, it looks like right now, so I'm just going to stick to them and then just prove it at the end in equation 2. So I'm going to take my value of n and put it back into equation 3. Okay? So notice we're only working with 2 equations to start. Kind of highlight them. That guy and that guy. We're just working with these 2. So we take equation 3, m plus, now here's our value of n. Well, our value of n is negative 2. So plus negative 2 is equal to 1. Okay, so m minus 2 equals 1. M is equal to 3. Okay. According to this, m is equal to 3. That's with those 2. We got to make sure this is true now. So in order to prove this is true, these values need to work in equation 2. Equation 2 was negative 2m minus n was equal to negative 4, was it? Let's double check. So let's take our values of m and n and see if this is true. Negative 2, 3, minus negative 2 is negative 4. Gives us negative 6 plus 2 is equal to negative 4. Negative 4 is equal to negative 4. So it holds true. In other words, this point does lie on that plane because this did hold true. If it didn't hold true, so we found 2 values of 2 equations and then we plugged them into the third one and it wasn't true, that would mean that point did not lie on that plane.